Okay, here we go. Another live stream with Jungle Jargon. Let me see here. Okay, so I'm having some more discussions about the time light issue, speed of light, which is constant in the equations that they use, except the equations don't consider the fact that time and distance are variable. So the way you measure speed of anything is with time and distance, right? That's how you get a speed. But if those values of a second or the value of distance, a mile, a meter, a yard, a cubit, whatever, if that varies and changes, then it's going to change the speed. So this is what I'm trying to get people to understand. I'm having multiple discussions at the moment, and they're just not getting it. Some people just don't get it. One person admitted, yes, the speed of light does change. I got somebody to even admit it, but then he says, "Oh, it's not, but it won't change that much." Yeah, not locally, but over large distances, it will change considerably the speed, the actual observed speed of light. That's why you have superluminal motion of things in space that far exceed the speed of light because they're using our measures of time and distance, which is a shorter measure of distance and a slower measure of time. And they're projecting that into outer space where the distance is expanded and time's running faster. So, according to their observations, they measure the speed, and the speed exceeds the speed of light 7 times because they're using the wrong measures to measure the speed. When in fact, that superluminal motion is an observation to calibrate the measures of time and distance outside as you move out of a galaxy. It's literally an observation that can calibrate the measures of time and distance outside of a galaxy or as you move out of a galaxy. Same thing with explosions, supernova explosions or whatever. The clouds move faster than the speed of light. That was the first superluminal motion they found. Then they found these plasma jets shooting out. That's faster than the speed of light 7 times, they said. They wrote a paper saying it's 7 times faster than the speed of light. And then they backtracked and said, oh, it's not even the speed of light. Now, how can you make such a difference between not even the speed of light to 7 times the speed of light? There's something wrong with their measures of time and distance. Okay, so I don't know if I think it might be too boring to get into to show these discussions, but I am having a couple of discussions here. Let me see. I don't want to get into too boring, but just to get an idea as to what the discussion progresses like, which just goes back and forth, back and forth. That's why it's probably too boring to show, because of how much it goes back and forth, back and forth, back and forth, back and forth. Okay, so this guy here, he was saying something, and then finally he just said nice. So this other guy comes along and says, he wants to know if I mean the speed is actually going faster than the speed of light. I mean, actually, if the speed of light is actually going faster, or if it just appears to be going faster. So then I'm trying to explain it to him, and he says, He says, okay, so it appears to slow down, depending which way you're going, and that actually is. So you're using concision. Thanks for clarifying. Concision, I think he means concise or with a definition. So then I say light appears to be slowing down because it is slowing down. Well, if you're going towards the black hole. And I tell them, do the thought experiment. Hold your hands about a foot apart, representing 186,000 miles, saying 1001, representing 1 second, while pretending to see imaginary photon going from one hand to the other. That is the speed of light. 1001 is 1 second. Your hands about a foot apart, representing 186,000 miles. That's the speed of light, 1001. That's the speed of light right there. Okay, now expand the distance, saying 1001 as fast as you can. You should notice that the speed of the imaginary photon in the thought experiment increases the farther away from the center of the galaxy it is. Well, as a representation. So here's what we do. See, here's what we do, right? Let me see, we're going here. Just to make this easier, which I've done before. So you hold your hands about a foot apart. Now this foot represents 186,000 miles, and you're going to say 1001 representing 1 second. So it'll be 1001. That is the speed of light. Okay, now I'm going to hold my hands apart like this, still representing 186,000 miles, because the measure of distance is never the same depending on the amount of gravity. And the speed of the rate of time is never the same, also depending on the amount of gravity. So when you move away from the galaxy, the distance is going to be greatly expanded, and the speed or the time is going to be faster. So instead of like this, 1001 being the speed of light, now this is the speed of light, 186,000 miles a second. It's going to be like this, 1001. Which speed is faster? Which speed is faster? So, I mean, I know it's hard for people to do the thought experiment. I'm trying to get this one guy here to do a thought experiment, and he just refuses to do it. I mean, so he's going back and forth. That's the thought experiment. And he just keeps on going. He keeps on talking about the mathematical equation. Show me the mathematical equation where c is not constant, because c is a symbol that stands for the speed of light being constant. But it's only constant in a mathematical construct of 186,000 miles a second, which I just showed doesn't keep the light constant. The light doesn't stay constant. So this is basically just going back and forth, back and forth. He Googled it. He Googled it and he said, oh, you're wrong. And then here's the equation. And it's got the c in there, c squared, right? The c squared. That's c is for a constant speed of light. But that constant speed of light is not constant. That's what I'm trying to get him to understand. And sometimes they confuse special relativity with general relativity. So I have to explain that. But it just goes back and forth, and he wants to see an equation. But then why say it appears and it is moving slower? it is moving slower. The path it takes is warped based on the mass, since the mass affects the curvature of space-time. And he's thinking, okay, speed of light constant. Okay, I'm saying that. All I'm saying is that there's a difference. When a layman read what you're saying, they may take it the wrong way. Okay, the speed of light is constant. It is the speed limit of the universe. Yeah, except for the fact that the measures of time and distance change. This is what they do. How can they not understand this? I know I'm not the only one who understands it, because I've seen people talk about the variable rate of time, but they forget about the variable rate of distance, variable measure of distance. It's both the variable rate of time and the variable measure of distance. They both compound the effect of changing the speed of light together. Together, they exaggerate the change in the speed of light. Okay, so it doesn't seem like he's following what I was saying. He must not have done the thought experiment. He just refuses to do the thought experiment. He says the speed of light never changes. Light has no frame reference, so it's unaffected by the slowing of time. He thinks it's unaffected by the slowing of time, or the speeding up of time. It is why the speed of light is constant. I showed you an equation above, because the equation doesn't consider the variable measures of distance or the variable rate of time. That's not in the equation, because if it was, light speed would not be constant. And he wants me to show an equation, but it's a variable. It's a variable equation. You'd have to have some computerized math to do that. So that's why you have to do the thought experiment, so you can see what's actually happening. Because if you don't do the thought experiment, you're not going to understand what's going on over large distances in deep outer space. See, while you're looking at the equation, you should notice that the path light takes is altered and not the speed itself. Okay, he's thinking about it's curved, and that's what slows it down. But it's not just the curve that slows it down, because I'm trying to explain to him that it's not the curve, because in the center it doesn't curve as much. Okay, if you're talking about a lens, I said, since you keep talking about the lens or lens effect, the lens is thicker in the middle, so light slows down more in the middle than the outer edges. So light is bent more on the outer edges. It's the outer edges that are bent more that makes the lens effect. The light in the middle slows down and is bent less. He's thinking it's the bending of the light that's causing the effect, but it's not just the bending. In fact, it's not even the bending. The reason why the light slows down in the middle is because there are more frames of reference, meaning there is more actual distance in the middle than in the outer edges, because the distance in the middle is contracted more. So it's almost like glass is more denser than air, so glass slows down the light more, and causes the lens effect. But the thing that people miss is not only that the light is bent, not only that time is being slowed down, but the distance is also being contracted, meaning there's more frames of reference which means it's more actual distance. So there's more frames of reference of 186,000 miles in that contracted space. So it travels farther. It has to travel farther. That's why it travels slower, because not only is time slowed down, but the distance is contracted, meaning that light is going to have to pass through more frames of reference, because I've already checked this out on a flat piece of paper. And I've counted the frames of reference. I mean, you don't have to, but you can. But if you don't do the thought experiments, if you don't go through it, you're just not ever going to understand it. Okay. And he says, you do not understand what light has no frame of reference means. It's not dependent on time being constant. Work out the equation with C in it. But the thing is, you can't do an equation with C in it because it's not constant. You're assuming that the speed of light is constant, but it's constant only in a frame of reference. In a particular given frame of reference, it's constant. But if you changed the measures to measure the speed, you're going to change the speed. I'm a mechanic. How can people not understand it? If you're going 60 kilometer an hour and then all of a sudden you go 60 miles an hour, you change the speed. You're going faster because you changed the measure of distance. It's really not complicated. So, but he wants an equation and it just keeps on going back and forth. And so he finally says, I want an equation. I want an equation. I said the equation is the thought experiment. It's a variable equation that the thought experiment will show. It's a variable equation that the thought experiment will show. You do the thought experiment, and that is the equation. If you want to put that in writing, go ahead. You'll need a computer to do it. So I'm going to ask you one more time, give me an equation with C in it and show me how it slows down. If not, then take care. And then, of course, I say C is not going to be in the equation because light speed is not constant over large distances. Anyways, that's basically the gist of the conversations that I have with people. There's another one here. Everybody has their own approach. Everybody has a different approach. And this one started out with somebody, and then this other guy picks up here. He's talking about redshift, so I have to talk about redshift. I have to explain that what redshift is. I said, well, he says it's based on observations, and I said those aren't observations that they have. Big Bang is not an observation. The expansion of space is not an observation. Dark matter isn't an observation. It's not an observation. So, okay. Anyways, kind of get the gist of it anyways. See what I got going on, if I got any recent responses. Okay. I guess everybody pretty much gave up. this one, still talking about redshift. And this one, what math is wrong? This is the other one. The one in general and special relativity showed me exactly where the math is wrong. I did. The math is wrong with the letter C because light is not constant when the measures of time and distance change. It can't be constant. When you change the parameters to measure speed, the speed is not going to be the same. It's that simple. And people just don't get it. So that's basically about it, I guess, for right now. Just double check here. I must have an old browser or something. I'm hesitating to change my whatchamacallit things. Even though I'm having a lot of trouble with this one here. They want me to change it, to update it. Okay, he's going to ask me one more time. And I say C is not going to be in the equation because light speed is not constant over large distances. Anyway, so there we go. That's about it. And either I bored everybody out of their minds or nobody woke up yet because they're watching cartoons or something. If that's still a thing. I guess it's not even still a thing. But anyways, that's about it. Enough of my ranting and raving and stuff, but I don't know how these people can't understand this. I don't know how they can't get it. It's like, I'm not the smartest person in the world. I'm not the brightest person in the world, but I am a mechanic and I do understand variable speeds. I built a variable speed transmission. I have a working model of a variable speed transmission, which turned out to be basically the same thing as an automatic transmission, except with a little bit more involved. But I know what variable speeds are. When you have a variable speed transmission, you're changing the gear ratio without going through gears. So the variable speed gear ratio means the gear ratio is changing without changing gears. But that's not exactly what's going on. Well, maybe it is, but maybe a better way to understand it is that if you're going 60 kilometers an hour and then you change from going 60 kilometer an hours, instead of the kilometers, you go to miles. Now you're going 60 miles an hour, which is a different measure. 60 miles is faster. 60 miles an hour is faster than 60 kilometers an hour. Then, if you go 60 miles every half hour, you're going even faster. You're just going that much faster because you change the measure of time. You change the measure of time to be faster, and you change the measure of distance to be larger. It increases the speed. It's not complicated. It's so elementary if you're into science and math and geometry and mechanics and everything, it's so simple. It's so simple, and yet these people can't wrap their heads around it. The fact that over large distances, not locally, of course, because locally the measures of time and distance don't change. Locally, when you look at a cat or a squirrel or a bird, you're looking at the same measures of time and distance. Everywhere you look, it's the same measure of time and distance. So locally, it's flat. The speed of light is constant locally. The Earth is flat locally, but Earth is not flat locally. I mean, over large distances. If you back up and look from a long ways away, the Earth is not flat. It's round, which is not flat. It's the same thing here. The speed of light is constant locally. But if you're going from the center of the galaxy to all the way outside of the galaxy, now the speed of light changes because you're changing the measures of time and distance. The farther you get away from the center of the galaxy, the more the measures of time and distance change because of gravity. It's an observed phenomenon. We know the clocks change. They just change so minutely, it doesn't make a difference. We've detected gravitational waves, but it's so minute locally that we can't even detect it unless we have extreme instruments to detect the small variations in measures of time and distance. It's like a vibration, a fluctuation in distance, like this. It's just a fluctuation in distance like this, and it goes whoop. When neutron stars collide or black holes collide, it causes a small fluctuation in distance like that. It's detectable. We've detected it. It's observed. But locally, it's so small, it's insignificant. But then when you get away from the gravity of the solar system, you get away from the gravity of the galaxy, then there's no more gravity to slow down time, and there's no more gravity to contract distance. So we can't use our contracted measures of distance and our slow rate of time. We can't project that into outer space and say these are the measures. No, the measures are not the same when you get away from the center of the galaxy, like where we are inside of a galaxy. I mean, this stuff is so simple. It's annoying. It's really annoying that people can't pick up on it. Of course, people are like sheep. They like to follow the crowd. If somebody goes, then they'll go along with it or something like that. Or some more people go, then maybe they'll join. But just a few people go, they don't want to go there because people are afraid like that. I don't know. It's just the nature of people. They're like sheep, right? But they follow the crowd. And I don't want to get into too much, and I don't even know how much significance it has, but I am supposedly or probably or possibly I am descended from Dan, who had a prophetic statement made for him that he would be a serpent in a way that he would knock the rider off the horse. And that seems like the story of my life. But anyway, it's I don't know. Anyways, and it's not just me, it's the rest of our entire family's same way, same nature. And I guess that's about it. Everybody, God bless everybody. Take care. And follow the truth. Follow the evidence. Follow the facts. Matter and energy can't make themselves. Matter and energy can't direct themselves. So we have a creator that made matter, ordered matter, where most of the most common elements we can't live without. Most of the most common elements in the universe we can't live without. It's like the universe was made for our existence, and then we were ordered out of those elements with written programming to order us to be humans instead of a chinchilla or a squirrel or something. It's not complicated. So stay close to the truth, stay close to the facts and the observations and the evidence, and you can't go wrong. God bless everybody. Take care.